All right, hi everyone. This is Larry Mussolino. I wanted to record a video for the Module 7 homework in my labs, give you a starting point on a few of the examples. Let me start here with number 13. Again, this is the Module 7 homework. And so this one is on optimizing, and they're asking us for minimum cost. So it says you're going to be constructing an open box with a square base. The volume is 128 cubic feet. The material for the bottom costs $4 a square foot, and the material for sides costs $8 a square foot. What dimensions will result in the least expensive box, the minimum cost? All right, well, we need an equation for cost. So step one is going to be find an expression for the cost. Step two is going to be to take the derivative and set it equal to zero. By taking a derivative and set it equal to zero, you can either maximize or minimize this function. And of course, we're going to be minimizing cost. All right, so let's come up with an equation for cost. Now, it's a good idea to draw a diagram here. So they're telling us it's a square base, and the box is going to have some height that we don't know. So let me try to draw this. So here's the box they're talking about. The base is square. So if the base is marked X and X, the height we can label as H, we can label as Y. Of course, we can label this whatever we want, but they did say to use X to represent the length of one side of the base. All right, let's go to part A. It says, express the cost in terms of X. All right, well, let me think about the cost here. For the cost function, I'm going to need the cost of the base plus the cost of the four sides. Now, remember, they said this is an open box. That means there's no top to this box. All right, let's think about the cost of the base. Well, the area of the base is X times X, so that's X squared. And for each square foot, it's going to cost $4, so I'm going to put a 4 in front. Let me come to the sides of the box. Well, if you think about this side here, the area is X times H. But there's four sides, so I got to multiply it by 4. And the cost is $8 a square foot, so I got to multiply it by 8. So what I'm ending up here is that the cost function is 4x squared plus 32xh. But I don't want to leave the cost function like this because we want it just in terms of x. So I'd like to somehow get rid of or substitute for this h. Well, they did tell us that the volume is 128. Well, the volume of this box is just x times h. So that's x squared h equals 128. Let me solve this equation for h. I'll divide both sides by x squared. So h is 128 over x squared. So let me plug that in or substitute that for this h. That means I can get rid of h and just have a cost function with x alone. So let's plug that in. In place of h, I'm going to drop in 128 over x squared. All right, let's multiply this out. 32 times 128 is 4096. There's an x on top and an x squared on the bottom. That leaves me just an x on the bottom. All right, so we just found the cost function. Let's take the derivative. Let's go to step 2. We want to take the derivative and set equals 0. Before I do that, let me just rewrite this cost function as 4096x to the negative 1. So I just took this x and moved it up to the top of the fraction. That would flip the exponent from 1 to negative 1. Now I could take the derivative. All right, so let's do c prime derivative. I'm going to use the power rule. This exponent 2 comes down and multiplies the 4, so that's 8x. Negative 1 multiplies the 4096. That's going to be minus 4096x to the negative 2. But we want to set this equal to 0 to find a minimum. All right, let me move x to the negative 2 down to the bottom, so it's going to be over x squared. I'll add 4096 over x squared to both sides. All right, well, let me solve this equation. I'm going to get rid of this denominator. I can multiply both sides by x squared here. You can also cross multiply here, but I'll just multiply both sides by x squared. That means 4096 equals 8x to the third. Divide both sides by 8. So it looks like we have 512 equals x to the third. Well, if you take the cube root of both sides, you end up with x equals 8. So this base is x equal 8. Well, they also want to know what is the height of the box. Well, we have an equation for height. We have that h is 128 over x squared. But now we know that x is 2, so this is going to be 128 over 2 squared. And if you work that out, that's going to be 128 over, over 8 squared. Our x was 8 here, 8 squared. So that's going to be 128 over 64. That's 2. So the height is 2. Last question, what is the actual minimum cost of the box? Well, we know the cost is this expression right here. But now we know x and we know h, so we can plug in. So the actual cost is going to be 4 times 8 squared plus 8 times 4 times 8 times 2. And if you work this out, this works out to be 768. So that's the minimum cost to build this box. Okay, so the key part here was figuring out a function for the cost and then taking the derivative and setting it equal to 0. That's the way you can maximize or minimize a function. All right, let's take a look here. This is number 15. And on this one, they're going to ask us to find what's called the antiderivative. So an antiderivative, sometimes we call this an integration, an integral. And what this is doing is taking we use this integration symbol, we're taking a derivative function and we're trying to get back to the starting function. Let me give you an example. How about if we wanted to know what function has its derivative as x squared? Well, the answer is x to the 3 over 3. Because if you take the derivative of x to the 3 over 3, it gets you back to x squared. So this is the derivative process, but backwards. That's why it's called antiderivative. Well, there's a formula for this. It says if you have the integral of x to any exponent, the way you work this out is you add 1 to the exponent and divide by n plus 1. Now, if there's a constant in front of x, you could just copy that constant with you. So let's work out part A here. It says, what's the integral of 5x to the 4 dx? Dx is an indicator that x is the variable of interest here. Well, the way I'm going to do this is I'm going to copy the 5 over because that's just a constant in front. So this 5 gets copied. Now, I'm going to use this power rule that I just mentioned to work out the integral of x to the 4. Well, I'm going to add 1 to the exponent. That makes it x to the 5 divided by that same constant 5. So I'm ending up with 5 times x to the 5 over 5. But of course, 5 on top cancels 5 on the bottom. It leaves me just x to the 5. So that's the answer to part A. All right, let's do part B. It just says, what's the integral of x to the 3? Well, the rule is you add 1 to the exponent. That's going to make it x to the 4 divided by that same exponent, 4. So that's the answer to part B. All right, let's do part C. They want us to integrate x squared minus 9x plus 14. Let me mention one other item. If you take the integral of just a constant, that works out to be the constant times x. For example, the integral of 5 is going to be 5x. All right, let's work it out. The integral of x squared is x to the 3rd over 3. This 9, I'm just going to copy with me because that's a constant. Then I'm taking the integral of x to the 1. That's going to be x to the 2 over 2. How about the integral of 14? Well, that's the integral of a constant. That is just 14x. So here is the answer to part C. Okay, so this rule is very important for finding the integral of x to an exponent. All right, let's do a couple more. Let's come here to number 16. So let me write the rule down again, because our rule, the integral of x to the n dx, is x to the n plus 1 over n plus 1. This rule applies even if the exponents are fractions, even if the exponents are negative numbers. So this rule is applicable to any exponent except n equals -1 cannot be used in this formula, but any other exponent can be used. So let's do part A. It's asking, what's the integral of 2 over 9 x to the -1/9? Well, this 2 over 9 is a constant in front. I just copy it over. All right, let's take the integral of x to the -1/9. Let me write it out. We're going to add 1 to that exponent and divide by that same expression, -1 over 9 plus 1. All right, well, let's work this out. -1/9 plus 1, let's work it up here. -1/9 plus 1, that's the same as -1/9 plus 9 over 9. So that's just going to be x to the 8 over 9 divided by 8 over 9. All right, well, what we could do here is when you are dividing one fraction by another, you leave the top fraction and flip the bottom fraction to a multiplication like this. I'm going to flip this bottom fraction upside down and change it to a multiplication. I have a 9 top and bottom cancels out. 2 over 8 simplifies to 1/4, so I have 1/4 x to the 8 over 9. Okay, so again, this rule applies even if the exponents are messy fractions. And even if they're negative. Let's do part B. Integral 1 over 9 x to the -2 over 9 dx. All right, the 1 over 9 is a constant in front. I'm just going to copy it. All right, now we're going to add 1 to this exponent, -2 over 9. That's going to be 7 over 9 divided by 7 over 9. Well, again, I'm going to take that bottom fraction and change it to be multiplication and flip it upside down. 9 cancels top and bottom, so it looks like we have 1 over 7 x to the 7 over 9. All right, let's do one more example here. Example C, integral -1 over 9 x to the -10 over 9. All right, I'm going to copy the -1 over 9 down. All right, now I'm going to be adding 1. So our exponent is -10 over 9, but I'm going to be adding 1, which is 9 over 9. That's -1 over 9. So -1 over 9 divided by -1 over 9. All right, well, let me keep the top of the fraction, x to the -1 over 9, but then I'm going to take this bottom fraction and flip it upside down and multiply it. So it's going to be times 9 over 1 with a negative sign. This 9 cancels top and bottom. I have a negative times a negative, so that's going to be positive. So it looks like I'm just ending up with x to the -1 over 9 for the answer here for part C. All right. Let's do another one, maybe one more here. Let's see. Let's do this one. This was a little different. This says solve an initial value problem. Well, what that's asking you to do is normally when you take an integral, let's say x to the 2 dx, you typically write as x to the 3 over 3 plus some arbitrary constant c. The reason is if you were to take the derivative of this answer, you would get back to x squared, because when you take the derivative of any constant, that's 0. Well, when they ask you to solve an initial value problem, they're going to give you enough information to solve for c. So they want you to find the actual numeric value for c. All right, let's do it. So they're giving us dy dx. We want to get back to y. So y is going to be the integral of 1 over x squared minus x dx. Let me move this x to the 2 upstairs so we can use that power rule. So this is going to be the integral of x to the negative 2, subtract x dx. All right, well, I'm going to add 1 to this exponent. That's going to be x to the negative 1 divided by negative 1. Here, the integral of x to the 1 is x to the 2 over 2. And I'm going to add that arbitrary constant. All right, so really what we have here, let me write it up here. It's going to be a negative 1 over x minus x to the 2 over 2 plus c. But remember, they want us to find c. Well, they gave us an xy pair. They said y of 6 equals 5. What they're really telling you here is the x value is 6, the y value is 5. So let's go plug those numbers in. The y value is 5. The x value is 6. This is negative 1 over 6 minus 6 squared over 2 plus c. Well, this is an equation I can solve for c. Let's see here. 6 squared is 36. 36 divided by 2 is 18. All right, let me add everything over to the left side. So it's going to be 5 plus 1/6 plus 18. That's equal to c. All right, 5 plus 18 is 23. So 23 plus 1/6. Let's get common denominator. So I'm going to take this 23 and multiply it by 6 over 6. So c is going to be 138 over 6 plus 1 over 6. So c is 139 over 6. So now I'm going to come back to this equation and write the final result here. Y equals negative 1 over x minus x squared over 2. But c, we just figured out, is 139 over 6. So when they say initial value, they're giving you an initial xy point that you can plug into this equation and allow you to calculate the value of c. All right, hope this is helpful as you are getting started in the Module 7 homework.